Great. Thank you so much. Thanks. It's a pleasure to be here. It's a lot of dedication for everyone to show up on a Saturday morning, so it's wonderful to see people on this session. I'm going to talk about applied AI in health, and it's supposed to be AI, artificial intelligence, from compute to care. The objectives for this talk are actually very simple. Understand basic concepts of data science, AI, machine learning, and deep learning. This crowd is probably fairly familiar with all that, so I'll try and be fairly quick around that. And then get into really understanding applications of AI in healthcare and review basic challenges in applying AI to healthcare. Sir William Osler was famously quoted as saying, "Medicine is a science of uncertainty and an art of probability." There's a lot of uncertainty in medicine. If you really think about it, the human body is composed of 70 to 100 trillion cells. In each of these cells, there's about 100 trillion atoms. All it takes is for one thing to go wrong and you have disease. As far as we know, some of our best statistics is there's over 10,000, look at the World Health Organization, around 30,000 diseases that we know of. That's just the tip of the iceberg. We don't know of so many other diseases that are out there because there's so many other things that could go wrong. But the ones we do know, about 10 to 30,000. Now, how much of this do we really understand? Because if we understood all of these diseases, we'd be able to fix all of these diseases. The reality is that about 500 of these diseases have US FDA approved treatments. 500. That's it. So there's a lot that we don't know still. Now, that being said, it's not for a lack of data. We actually have a lot of data. In fact, there was a review that was done by Royal Bank of Canada that estimated the compound annual growth rate for data, and healthcare outpaces every other industry. So we're actually quite data rich. So what's the issue? What clinicians want is to provide the best possible care for the patients we serve. So what does that entail? It entails a whole bunch of things, but there's a lot of challenges to those things. So we need to keep on top of the latest research findings. But what we struggle with is a new study is published every 2 minutes. So there's literally over 30 million studies that you can access through PubMed and Medline. We have to constantly monitor patients, but the average physician may spend less than 15 minutes per day reviewing a typical patient because of all the other bureaucratic responsibilities and paperwork and such that they have. We have to process an incredible amount of complex information, social history, labs, monitors, orders, data from monitors, vitals, medical imaging, medications, just to name a few. And we have to put that all up here. The problem is Miller from the 1950s, who's a famous psychologist, concluded that the average human can only process 7 plus or minus 2 things at the same time. 7. It's not a lot. And we know that a complex medical decision nowadays often involves processing about 1,000 different parameters. So of course we're going to struggle. We have to assimilate all the right information at the right time for the right patient. Currently, and this is how well we're doing, over 30% of patients do not get treatments of proven effectiveness. And more than 20% of patients, that's more than 1 in 5, get care that is not needed or potentially harmful. So you can imagine there's a lot of room to improve, but we're bound by human limitations. So what's AI? What is this artificial intelligence thing? I'm going to very briefly go through my very basic definition of AI. There's a nice paper by Marveo et al. In the BMJ that actually kind of layers AI, machine learning, and deep learning. The way they describe artificial intelligence is it relates to programs that allow machines to mimic human behavior. You know, my own personal understanding of AI is that it's really the ability for computers to be able to recognize patterns and complex relationships in data. And the computers will be able to do it in a very sophisticated way, in a very rapid manner. Machine learning is a subset of AI. So in many statistical models, you'll say, all right, well, age matters this much versus sex matters this much versus socioeconomic status matters this much. And you actually identify what those relationships are and the weighting of those relationships. What machine learning does is it says, I've got a ton of data, I'm going to learn it myself. So basically, these are techniques that enable computers to improve tasks, at tasks without explicitly being programmed. So the machine kind of learns on its own. And then deep learning is a subset of machine learning with just more data and more complexity. It's kind of really all it is. In the interest of time, I'm going to keep it to that. Happy to answer more questions in the discussion if there are any. So how does this all fit? How does AI kind of help us in clinical care and medicine? If you break it down in very basic terms, some components involve diagnosis, prognosis, and treatment. So if you think about it, how do you make a diagnosis? Some cases, it's very simple. A lab test will nail it. But in other cases, it's a bit more complicated, right? We have to take different pieces of information. And sometimes we don't have pieces that we would like to have, but we have to make a diagnosis. So for example, in asthma, you think that would be pretty good at this. There are several studies out there that suggest that people who've been diagnosed with asthma, who are being treated for asthma with inhaled corticosteroids and full-on management, over 30% of them don't actually have asthma. So clearly we haven't really made a good diagnosis, and maybe we need a bit more help doing a better job of making a proper diagnosis. So AI can help around grabbing a whole bunch of data and really doing classification tasks to get a better handle on diagnosis. So let's say you've made the diagnosis. Now, how do you determine treatment? Well, first you have to kind of think, well, is this patient really going to deteriorate quickly? Because if they are, I'm going to be more aggressive with my treatment. And maybe I'm going to try therapies that I know have more efficacy, but maybe more side effects. But if they're not so bad, they're going to do okay. Maybe have a little bit more time. I'll go safe. I'll go something that's more tolerable, a little bit less efficacy, but it'll probably be better for the patient. We are terrible at prognosis. There's study after study after study showing how clinicians are just awful at prognosis. But that's what drives how we manage our patients. Can we have help? Absolutely. I think AI can play a role in terms of understanding what the prognosis of a patient is. And then, of course, there's treatment. Treatment can be very complicated. So if you look at multiple sclerosis, for example, when you treat a patient with an MS drug, how do you determine which one to use? The reality is we don't know. We pick one. It could be any one of these options. We see how they do, and then we revisit. That happens quite a bit in many conditions. We look at depression, for example, as well. Which serotonin-specific reuptake inhibitor are you going to use? Are you going to use one? Are you going to use a tricyclic? Are you going to use an SNRI? There's all sorts of options. We often don't do a great job at picking which one, though, because we struggle about lack of information, but also too much information and how to use it properly. So I'm going to step back and talk a little bit about artificial intelligence in health, the Greater Toronto Area, or the GTA scene. So we have this kind of really nice environment at the University of Toronto. We have these incredible departments and schools. Our Department of Statistics is typically among the top 10 in the world. Our computer science is among the top 10 in the world. Engineering is top 25. Education is top 5 in the world. Our medical schools typically rank top 5 in the world. We have the Vector Institute, which is a world-renowned AI institute. A lot of really, really nice pieces to enable AI in our environment. And of course, something that's really amazing is that we have this really nice ecosystem of academic called the Toronto Academic Health Science Network that spans University of Toronto and affiliated academic hospitals. So lots of hospitals, lots of technical skill sets. It's a pretty nice environment. These are some of the examples of the things that go on. At the Toronto General Hospital, there are some lung transplant docs who said, when we manage patients, that prognosis thing is not something we're very good at. So they've developed an algorithm that will predict 1 in 5 year survival with likely causes of death. So they understand that a patient may have 2 years before they have an untimely event, and they likely will die because of cardiovascular causes. So they know what to focus on. And I think that's pretty exciting. Again, it's at the research stage. At Sunnybrook Hospital, again, at the research stage, there are a group of experts, clinicians and engineers and computer scientists working together to develop an algorithm around breast cancer. The issue with breast cancer treatment is they're first-line therapy, but many patients will fail first line. How do you know who those patients are? Because you'd ideally like to get them alternative therapies right at the beginning, because you're going to waste a few months of time and maybe subject patients to toxicity that they may not need to have. We're not very good at that either. But they've developed an algorithm that can predict ahead of time response to chemotherapy with 96% accuracy, which is pretty exciting. Now, the issue we have is that our hospitals don't often talk a lot with each other. Imagine lots of silos, right? The other issue we have, how do you get these things into practice? Because they're so exciting, but we need to be able to coordinate ourselves to actually use these algorithms for clinical care. We received a very generous donation from the Temerty family. The Temerty family donated $250 million to what is now the Temerty Faculty of Medicine at the University of Toronto. And about 10% of that amount was actually for a dedicated center for AI in medicine. And the whole function is to bring a lot of people together. So we have three themes. The first theme is education. So we focus on things like bringing world-renowned speakers. We've had speakers from MIT, Harvard, Oxford, Michigan. We've had Eric Topol speak, world-renowned clinicians and computer scientists to talk to our community. We have a learner series where we have students coming together, and it's very, very multidisciplinary. Typically, we have 10 of these a year. We have a medical student and then a non-medical student, so an engineering student or a comp sci student present. And students from all sorts of disciplines come together and learn from each other, which I think is very exciting. We also offer summer studentships. We have workshops and training and all that sort of good stuff. If people want to learn, we have a curated list of education materials around AI. There's lots of not so great materials, but there's some really good materials to learn. So our team has went through hundreds of different sources and summarized which ones we think are actually quite good. We also have a research team where we have 2 awards that we award each year. Last year, actually, we did 3, and this year it looks like we're going to do at least 3 as well. And the annual amount typically is about $500,000, not $400,000. Last year, we actually awarded Dr. Shaf Keshevji, who is actually looking at that algorithm that predicts survival in lung transplant, and Dr. Devin Singh, who is looking at eye disease, diagnosing eye disease in kids. We also have an infrastructure theme. And all of these themes are very much led by very multidisciplinary people. So for example, the education theme is led by a statistician and epidemiologist with 2 MD PhD students who are co-leads. The research theme is led by a computer scientist and a clinician, a cardiologist, ICU physician at Sick Kids. And they work together around the research theme. And the infrastructure theme is led by a computer scientist and a bioinformatician. So the infrastructure is really interesting because you can't really do AI without data. So how do you create an environment that houses data? Well, we're going to be spending anywhere from $3 to $5 million over the next 5 years. We actually have a functioning environment now on Google Cloud. So the concept is very simple. Investigators, researchers, teachers can put data on this platform, and we've developed an environment that is very friendly for AI. It has all the right tools, virtually unlimited compute, virtually unlimited capacity, so that people can go for teaching purposes as well as fun things like hackathons or even research projects where there's data housed in a proper environment that's made for AI. And this, as far as we know, is the best platform in the country for its purpose, and I would argue among the best in the world. Of course, none of this would be effective without community. So we're spending quite a bit of time and energy on how do we get people to work together. So currently we have almost 800 members just at the University of Toronto community alone. We're expanding our membership this fall, and we've invited 18 universities, I believe. We had just had a meeting just recently with 18 universities across Canada to expand membership. And we hope to increase membership to a few thousand members where we all can work together, from medicine to computer science to engineering to statistics to mathematics and so on. We believe that's what's going to drive culture change, when people come together and leverage technology and AI. I'm going to switch gears a bit and tell you about my other hat that I wear, is a focus on how do we bring AI to practice, because these are great technologies, but if we don't use them, they're really nice papers, but what else do you do with it, right? So first thing that I want to step back and do is tell you a little about how we learn from data science failures. So one of the first examples I'm going to give is around Microsoft. In 2016, Microsoft created this chatbot. It's called Tay. So what they did was they said, this chatbot is going to learn how to talk by learning how to talk to people. So we're actually going to put it out in the Twitter universe, and everyone's going to teach it how to talk. So what they did was they literally released Tay into the Twitter universe, and within 24 hours, they had to pull Tay back out because the Twitter trolls jumped on Tay and taught it to be extremely racist and misogynistic. How does this chatbot learn? Well, it learns what you give it. And of course, if there are racist and misogynistic people out there, that's what it's going to learn. And so the data it learns on is so critical to how it performs. Then, of course, is the example of Google. Incredible work developing an algorithm that detects diabetic retinopathy. And, fantastic work at that end. One of the big issues was that it was trained on pristine images in more of a research environment. And it was trained to detect diabetic retinopathy better than expert clinicians, which is super exciting. So the government in Thailand said, hey, you know what? We have this national campaign around diabetic retinopathy. It would be great if we could leverage this algorithm to help us diagnose patients more effectively and faster. And so they tried to deploy it, but there were lots and lots of deployment issues. For example, over 20% of images, I believe, are under poor lighting conditions, so the algorithm doesn't work very well. And then you have to reschedule patients, and then people get frustrated. So they had to pull that out fairly quickly. So the tech is advanced. There are companies out there now that actually have a more standardized solution, which is really exciting. But it is tough to get it done well. And of course, the last thing I want to say is that there's quite a bit out there around how tools are developed in the research environment that just cannot be translated. So there's a recent systematic review, for example, that looked at over 400 AI solutions in COVID, over 400. And they went through each of them. And what they concluded was that the number of solutions out of the over 400 that have been published that could actually be deployed in clinical practice was zero. None of them could actually be deployed. So we have a lot of work to do. So the hospital that I come from is part of Unity Health Toronto, St. Michael's Hospital. We're a tertiary care teaching hospital in downtown Toronto, established in 1892. We're basically Toronto's inner city hospital. We're one of 2 adult trauma centers in the greater Toronto area. We have about 500 beds, over 6,000 staff, over 900 physicians, over 1,600 nurses. How many patients do we see? In the emergency department, we have about 80,000 patients a year, 80,000 visits, over 500,000 ambulatory visits, and over 25,000 inpatient visits. Now, why am I telling you all this? It's because there's a lot of data there. So if you multiply this by about 15 years of historical data, it's a good amount of data to work with. We also have a research institute, and we're fully affiliated with the University of Toronto. So what did we do? We set up this group. First of all, we needed to fix our data environment, because in most hospitals, the data environment is not very good. At St. Michael's alone, we have over 50 different source systems that don't talk to each other. So we spent several years developing a proper data environment to enable AI. Then we hired a team of data scientists. Who did we hire? Well, we're not just going to hire clinicians. Actually, none of our folks are clinicians. I shouldn't say that, actually, maybe a couple are, but the vast majority are not clinicians. The way we hire data scientists is first, we actually had to understand problems. So we actually talked to our end users, our doctors, our nurses, our physiotherapists, our pharmacists, our administrative decision makers. What are the things you struggle with? And we quickly realized there was 3 streams of data scientists that we needed. The first was around traditional statistics, so statisticians. The second was in operations research engineering, so simulation modeling and optimization came up. And then the third was computer science, natural language processing, machine learning, deep learning, vision learning. Those sorts of data scientists are the ones we needed. So those are who we hired. The data scientists came in and they said, well, we need deep learning servers, or at least go to the cloud or something to that effect. Well, no, we can't because of privacy issues. So we had to build an internal environment. And we brought in TensorFlow, PyTorch, Python, R, Garobi, all these sorts of tools that our data scientists needed, and the compute environment and the data. Great, right? This is where most people stop, and this is why most people fail. It can't just be about the data scientists. In fact, one of our rules is the data scientists don't get to ask the questions. The questions have to come from the clinicians. Because you can imagine it is insane for me to say to one of my data scientists, hey, you know, this one issue in stroke, and I'll tell you the subtype of stroke and the subtype of patient and these sorts of medications that are available, they're gonna not know what I'm talking about. Now, it's also unfair for me to say to a neurologist, hey, can you build me a neural network? Maybe if I'm looking at images of 3D convolutional neural net, most clinicians will look at me and say, I have no idea what you're talking about. But I know the problems my patients face and what I face. That's what we need. So the way our model works is our clinicians and our administrative decision makers get to ask the questions. They don't have to know what AI or machine learning is, but they know what the problems are. That's where we focus. We then pair our clinicians and our administrative decision makers with our data science team. And it's a very structured process. So I'm happy to go through that in the question and answer period if you like, but we have a very structured process on how we engage and the requirements for engagement before we embark on a project. The way we're structured is we have a data integration governance team. They are just focused on building data pipelines, cleaning data, curating it, all that sort of good stuff. Then we have an advanced analytics team that actually does the modeling, the machine learning algorithms, all that sort of stuff. Then, of course, we have an engineering team, not engineering, a product development team that actually then sits back and says, you know what, we need to develop a solution that's human friendly. So the head of our product development team actually is an artist, if you can imagine. Now, he's an artist who had maybe a midlife crisis, but he actually went and did a Master of Science in Applied Computing in machine learning. So he has that perspective on things, and he actually now focuses on human AI interaction. He has human factors experts and software developers on his team to actually develop products that people want to use. And that's absolutely critical. And then, of course, we've been talking with our institution that are really interested in us trying to commercialize some of the work that we do. One of the other things I've learned is a lot of data scientists, we're not very good at project management. So we actually have a whole project management team that is very focused on timelines, milestones, deliverables, and execution, because that becomes really, really important. Here's just a snapshot of the bunch of things that we work on. We've deployed, my team tells me now we've deployed over 40 solutions into clinical practice. Typically, we work on 10, maybe 15 things at any one point in time, and then we deploy. Project duration is about typically 3 to 6 months. Some projects take longer, some projects take less time. So I'm going to give you a case example. This is an actual patient from our hospital from a few years ago. Miss RW, she was a 73-year-old retired nurse, came in with an inflamed gallbladder or cholecystitis. It's a fairly common condition. You know, it's nothing to hum and haw about. So should be fairly standard. Had a diagnostic procedure done. The plan was to discharge her home for the next day. Unfortunately, the physician was called that evening. The patient had shortness of breath. So the physician ordered chest X-ray and labs. The vital signs were checked twice overnight. And the next morning, the physician was called for decreased blood pressure. Blood pressure suddenly dropped. The patient deteriorated, and unfortunately, she died that day. The family was understandably distraught at the sudden deterioration and said we would never left her bedside because she was suffering. The reality is 1 in 12 internal medicine patients will die in the hospital. So what can you do? And our internists came to us and they said, look, here's what we could have done. We increased monitoring. We could have kept a closer eye on her, increased monitoring to Q4. We could have looked for signs of sepsis, thought about initiating antibiotics. We could have called the critical care response team, told them to be on standby because we think this is a high-risk patient. We could have called the palliative care team. So if we knew there was nothing we could do for this patient, at least she could have died a comfortable, dignified death. We could have communicated to the patient and to the family. We could have done this much earlier, but we didn't know. So their challenge to us is, can we predict who will die so we can intervene earlier? And so we did. If you're a patient at St. Michael's Hospital, it is not an option. You will be monitored by artificial intelligence. So the way our algorithm works is every hour on the hour, it grabs data from all of our internal medicine patients, and it categorizes patients as low, medium, and high risk. And what it predicts is death or ICU transfer at least 48 hours in advance. So you can imagine, as soon as it reaches the high risk threshold, it pages the medical team. The medical team then comes and sees the patient, and it has care pathways that they can then consider. The medical care team is supposed to see the patient within the hour of being alarmed. So all of this is live. It's working again every hour, 24/7. We've had it up and running since October of 2020. So when we launched, we saw stories like this come about. The resident on call overnight received a high-risk alert around 11 p.m. She went and reviewed the chart and saw the patient as per the recommended protocol. He was relatively stable. Approximately 2 hours later, she received a call from the nurse that the patient was decompensating. As she already knew the patient, she was able to quickly assess at the bedside and get the ICU team involved. The patient went to the ICU, but did not thankfully have a respiratory arrest, which was certainly a risk if the intervention had not been done as quickly. The resident feels that the AI program made a big impact. All right, what about death? Because that's what we really, really want to focus on, right? Did people die? Well, here's some preliminary data, time series data looking at mortality rates among high-risk general internal medicine patients over time. We do have a paper that we're submitting for publication soon. If we look at January to March of 2020, this is when our COVID patients started coming in. This was prior to launching our tool. If we compared the mortality rate in this period compared to the past 4 years of historical data, we saw a 35% increase in mortality. April to June, we had many more COVID patients in the hospital, a 70% increase in mortality. When we look at July to September, we had a good summer, not as many COVID patients. We still saw a 37% increase in mortality. This is when we decided to deploy the solution. Despite much higher cases of COVID, we still saw significant reductions in mortality. So we feel that this algorithm actually makes a difference and can save lives. So what are some of the logistic considerations? Well, performance metrics and evaluation, model performance. It's all about model performance when we look at the algorithm itself. Precision and recall. How many false positives do you have? Are you going to result in alarm fatigue if you have too many false positives? Workflow, it then bleeds into that. How often do you report? Initially, we launched the algorithm to run every 8 hours, but our clinician said, this is actually working, so can we have it every hour? So now we run it every hour. Our false alarm rate is much lower than many algorithms, which actually leads to clinical adoption. Clinical validation. We actually spent a few months going up to the floors and asking our doctors, nurses, and our residents, do you think this patient's going to die or go to the ICU? So we have over 3,000 clinician predictions. And when we compare it to our algorithm, we've shown that it performs significantly better than clinician prediction alone. That's what we needed to get clinician buy-in. Because many algorithms, if they have ridiculously good accuracy, but our clinician accuracy is even better, the algorithm isn't useful. And oftentimes we don't do that level of testing. Of course, there's all sorts of silent testing that we do as well. Privacy and confidentiality, you can imagine. Some people may be concerned with data scientists accessing identified data, because if we identify Mr. Jones as high risk, we need to be able to know it's Mr. Jones. So we need identified data. There's all sorts of governance and access issues that I'm happy to elaborate on in the Q&A. Risk and liability, you can imagine clinicians would come to us and say, all right, so if this algorithm says this patient's going to die, I don't believe it, and then the patient dies, do I get sued? So we actually had to reposition things to say this is not a decision-making tool, this is an information tool. So for example, as you would have a lab test, you just use it like that. It's one more piece of information that you have to make a decision around your patient. And of course, all sorts of issues with bias and equity to really test your algorithm that it doesn't underperform or overperform in one area versus another. Challenge though is we don't have great data on race or gender or socioeconomic status or education status. So we test that? Not really. So those are some of the limitations. All sorts of other algorithms. I'll just give you a few more examples before I end. We have a nurse resource team optimization algorithm. So this is where our operations research engineers came in to work with our nursing team. And very simple, there's some pockets of nurses that we need to optimize staffing on. We developed an algorithm within I think 8 weeks, deployed it at 2 hospitals with an estimated annual cost reduction of about $1 million a year. In our multiple sclerosis clinic, our residents and our fellows sometimes struggle with understanding patients. You can imagine these patients are chronic, 5-7 years of history. They just finished seeing a patient. Their next patient is in 10 minutes. How are they going to review 5 or 7 years of history? So what they've asked us to do is create a tool where, do you have an advanced natural language processing tool that can read through 5 or 7 years of history and just summarize in one visual, not much text, one visual, what's happening to the patient? So for example, did the patient have a relapse here and here 4 years ago, but look, they have 3 relapses in the past 18 months. What about T2 lesions? How many did they have? Oh, only 2? Okay. Well, what about drugs? Well, I tried this 3 years ago. It didn't work. Then we over this, and then now they're on a certain different type of drug. It has a visual, and it can do this in about 2 or 3 seconds. So it does this for all of our multiple sclerosis patients, and our team has been using it for several months now, which is helping, I think, provide better care. The homeless, this was a big issue for us during COVID because we have a fairly large homeless population in the downtown area. One of the issues you can imagine is homeless patients who test positive and actually go off to shelters, and you could have outbreaks in shelters. Our clinicians were having a really hard time assimilating the right information at the right time and actually trying to be able to predict, all right, is this going to be a high-risk patient? Are there going to be outbreaks here, here, and here? So we actually developed a tool that assimilated it very quickly within seconds for the right information they needed, and also alerted patients around there's going to be an outbreak here. So that people were more diligent around how they managed patients, which again I think was very helpful. If people want to learn more, we published a 3-part series in the Canadian Medical Association Journal just last year around how you implement these things into clinical practice. We also outline problems in the deployment of machine learning models in healthcare. And of course, how do you evaluate these things? There's a whole field of machine learning operations and evaluation that I think is very robust for future development. So I think it's really trying to align incredible minds that are doing ridiculously good research from all around the community here in Toronto, but all around the world, I would argue, and coupling them with people who can really deploy and get things into practice. This, I think, is the future of healthcare. It does include AI in a very big way, and I think it's going to result in better care for all of us. So I'd like to thank you, and I'll end there and happy to take any questions.
Thank you so much, Dr. Mamdani. It was absolutely a stunning presentation, and by all means opens our mind to see how it's really about finding the right problems, implementing them, and not just about understanding the research aspect, but seeing what part of the community deserves to be focused on during that time. See how your work at T-CAIREM has helped them identify these problems during time. So thank you again for an amazing presentation. The panel is, again, now open to question and answers from the audience, and or participants are more than welcome to type in their questions in the chat box or directly ask on the mic. In the meantime, while we get some questions, one thing that does come to our mind, which is the idea of, clearly we're seeing problems being identified, some on a very large scale and direct community driven as well. What is it that happens behind the scenes when it comes to prioritizing the right problems? And maybe this is something that goes into your process of implementing them later on.
Yeah, excellent question. We were actually worried that if we become too structured, nobody would come and want to play. But we were actually pleasantly surprised that there was quite a big interest and set of demand in our hospital and our clinicians. So the way the process works, and you'll understand when I describe it, why we were worried, is that we basically said, look, if you have a problem that you're excited about, that's great, but we need you to fill out a form. It's an intake form. It's 3 pages. So doesn't take a lot of time to fill out. But basically what it requires you to do is clearly articulate what the problem is. And that's really what we focused on. There's a famous quote from Einstein that said, if I had an hour to solve a problem, I would spend 55 minutes understanding the problem and 5 minutes developing the solution. So the understanding the problem becomes really key. Then we go into, well, how do you think data and AI can help? You don't have to know much about it, but if you could dream, how do you think it would help? Then we actually go, well, if we told you, if we developed a solution, what interventions do you have to affect change? Because if an algorithm tells you something and you have no interventions, it's not going to be impactful. So we need to know that you can intervene and your intervention is going to be effective. And then we ask about, what are the outcomes that you focus on? And we have a selection box. The box includes death, readmission, length of stay, human effort, cost, and other. If you click other, you're automatically deprioritized. So it's very clear in terms of the outcomes that we want to focus on. And so what we then do is we basically are very open to clinicians, and we say, look, if you actually prioritize all of this, we want to understand what sort of an impact that you're going to have. So take a best guess. You're going to reduce mortality by 10%. Great. That's what we're going to hold you on. Because now we have a clear understanding what the purpose is and what we want to achieve. The next thing we do is we say, all right, if you think it's a good idea, we need signatures. We need your program director, your medical director, and your division and department head to sign off. Because if it's only you who thinks it's a good idea, it's probably not a good idea. We need your community around you to back this up and say, no, this is what I have a problem with as well, and I would love a solution for it. And the last thing we ask our clinicians and our administrative decision makers, our end users, is you have to make time to engage with us. So for the next 3 to 6 months, whatever the estimation is for solution development, you will be at every single meeting that we have, every 2 weeks, at least 1 hour. In between, if we have questions, you will answer them. And you're going to lead most of these meetings because you know what the problems are. If you can't make that level of commitment, we're not going to take on the project. So it's a lot of skin in the game, I guess you could say, for the end users, and a lot of thoughtfulness that we need before we take on the projects.
Right. No, absolutely. And I think that's that's the investment that comes both ways. And we're seeing that from your point in supporting the problem, but then it comes from really the clinical environment, the healthcare providers, the researchers on site. And I think that's what drives the concept of the live labs that you're working around with. So really great to see that. We do have a question which is on the topic of now, considering how in such a short span of time, T-CAIREM has managed to create this very multidisciplinary community of engineers, designers, artists, and healthcare professionals. I'm sure there must be those challenges that must have come with bridging them together. And that's something that even at the Clinician Engineer Hub that we're quite interested to see. So what were some challenges that you faced and how did you sort of approach them when it comes to different fields?
Yeah, it's a great question. I'll be very blunt in one of my answers, but it's all about community and how do you get people who would normally not work together to work together? My more blunt answer is money. We offer funding opportunities that actually say, we know you don't have all the skill sets and this person doesn't have all the skill sets, but when you work together, it could be magical. So we're going to get you to work together as a requirement of this grant. And in order to be able to do some of this work, you have to work together with different disciplines. So we offer grants that are very multidisciplinary in nature, number one. Number two, we have community events for people and platforms. So what do I mean by that? I'll highlight two programs in our community. One is something called the Collaboration Hub. Basically, it's like a Kijiji for AI and health, or want ads, I guess you could say. So the concept is very simple. Anyone can put a posting. It's one page, very simple. So I'm going to give you the example of a neurologist again at Sunnybrook Hospital who says, I'm a neurologist. I have 4,000 head CTs and I want to do some really neat work in AI, but I don't know how to build a 3D convolutional neural network. Is there anyone who could help me? So they would put a posting out and they would say, here's my issue. Here's the data I have. Here's the expertise that I have. I don't have expertise in machine learning. I don't have any funding. So are there people who can help me? And then we have lots of computer scientists who will say, well, actually, I have funding, I have PhD students, but I don't have data or clinical expertise. So I'm going to work with you. So we've had about a dozen of these proposals come up. We've already matched half a dozen, and we're going to continue to match more because this is a venue that people can actually come together. The second thing that we are testing right now and going to launch very soon is something called Hive Hubs. So basically the concept here is anyone can raise their hand and say, I have an interest. I'll give you a concrete example. We were giving a talk to our gastroenterologist and they said, we really, really want to do AI in irritable bowel disease. We said, okay, there's probably 100 of you like that with different interests. So why don't we do this? We're going to build a platform. You can use that platform and you can create your community. So we need 5 of you. If 5 of you say, this is important to me, fill a one-pager out, we'll invite the entire community. So whoever's interested in AI and irritable bowel disease, this is the user group that you want to join. They're going to meet every 2 weeks or every month, however the chair wants. They have 6-month deliverables in terms of publications or grant applications that are multidisciplinary. They're going to tell us we want 50 people or 100 people or however many people. We want computer scientists, we want X, all that's outlined in the description. And then people can actually respond and actually attend those meetings. And this is where we actually have a forum for people who would normally not intersect to actually meet and intersect.
Right. And I think I love the idea where you've just created, again, going back to community where people are whom you're listening to, and that comes down to even professionals in different fields. So these forums are a great start and something all of us could look into on a global scale. That's wonderful.
Oh, thank you. It's all about, we have such a very wide range of interests, and we want to accommodate people and get people excited about it.
Thank you so much for this incredible talk, Dr. Mamdani. Oops. Oh, I think he froze for a second.
My pleasure.
Yes.
Oh.
Uh-oh.
Sorry, I don't know if I was frozen there for a second. I was just thanking you, and I just have a question. You mentioned, you couldn't use cloud computing and kind of have to create your own internal structure. So it's kind of a 2-part question. I want to know, how feasible that is for smaller institutions, and how to kind of get around some of that red tape with data privacy in medicine.
Yeah, it's a great question. I think from my perspective, it is a huge issue around on-prem versus cloud computing versus where you put data. We're going to get there in the healthcare sector. I think more and more hospitals are moving to cloud environments and they're becoming more comfortable with cloud environments. I would say some hospitals are probably further away than others. So if your hospital is a bit more progressive, I would try and advocate quite a bit for cloud-based compute. Um, so, for example, there's one hospital in Canada. It's actually a community hospital that is all cloud now. They're completely on the cloud, which is super exciting. Um, I think if your hospital is not so progressive, it's going to take 10 years before they get there, for example. I think it's going to be a matter of realistically getting infrastructure to build inside in short order. And this could be through grant funding or such, but you're going to have to create an environment. In terms of how people get around the sensitivity issues around identified versus de-identified data, if you're in the research space, it's a lot easier. We've created something called the Health Data Nexus on Google Cloud, as I mentioned in our infrastructure platform, where people can actually cut it, data, de-identify it, and host it on our cloud environment. So for example, when we formally launch the Health Data Nexus, it will have several data sets, one of which is from my hospital, patient-level de-identified data from our internal medicine unit, 15 to 20 patients worth of data. It will be on the environment, on GCP, publicly available. So researchers, when they want access to it, you don't need ethics. You don't need a detailed analysis plan. You need three things. Prove to us that you're a researcher from an accredited university. Show us that you have TCPS2 training, which most clinical researchers do. And read a data user agreement and click I agree. Access to data. It should be that simple. So these things are coming. They're going to shape culture. So I would say short answer is, if your hospital is progressive, push on the cloud environment because they're likely already slowly moving there. They just need a nudge. If your hospital is not progressive, think about getting resources. If it's research, use things like the Health Data Nexus because there's a platform there and there's going to be precedent around how to put data on there for research purposes.
Oh, thank you. That's really exciting to know that hospitals are moving towards that way, especially in Canada. It's been so slow, and sometimes it's frustrating. In the States, I see a lot of really interesting companies and hospitals doing incredible things, and so I'm happy that there's some hope and we're moving that direction. And there's platforms like you mentioned to get that data in a de-identified way that's secure from, as long as you're from the accredited university and have the training, you can access that.
Absolutely. Yeah, it's an exciting time.
Absolutely. We're still open for any further questions from the audience in this time. But in the meantime, Dr. Mamdani, is there sort of a message that comes to your mind, especially to the community of clinicians and engineers that you have for especially the student population who are currently in the midst of all the AI healthcare evolution that's going on? What is one thing that you'd like to share with them?
Yeah, usually I give a message to the older crowd. The younger crowd actually is so much smarter than we are. And I'm not trying to be overly complimentary. I really think this generation is incredibly brilliant, much more advanced than we are. We tend to kind of have this siloed approach of, I've been trained to focus on this lab question and this research question or this patient without really collaborating or going outside my walls. I see the younger generation is much more open and inclusive. I think that is going to be hands down the winning formula to everything, is to work with others you would normally never have worked with. Who would have thought that I would have an artist on my team to head up product development for AI solutions? I would never have thought about this 20 years ago. But when we have sorts of people bringing really transformative ideas, this is how you're going to change. Just another quick note, we actually launched a startup actually just a couple of weeks ago. And one of the things we struggled with was, if we have these solutions, how do we get it to other hospitals? Because they don't have the data environment that we do. They don't have the rapid, we're going to grab data, do ETLs, clean up the data, put it into an algorithm, spit it out in close to real time, like within seconds. How are we going to take it? So we actually looked far and wide. And the one group that we came up with was in the banking sector. In banking, they developed this. So TD has put in over $200 million investment to develop an AI engine using heavy machine learning, ML operations and machine learning operations processes. Incredible solution. So can we license that to then actually bring solutions to outside hospitals? Banking sector has it. We got to talk to the bankers. So we did, and they were very excited. But if you don't have these conversations with disciplines that are just so out there, you're not going to transform. So that's the one message that I would give to people here is go out of your comfort zone, look outside, work with people you never worked with before.
Excellent. I think it really summarizes not just the importance of collaborations, but even the energy that you bring to this presentation, to the vision of T-CAIREM, and something that I think we're all learning at different stages of our career paths. So thank you again, Dr. Mamdani. And this also sort of brings us closer to the end of this session. And it's been a pleasure having you, Dr. Mamdani, and even our audience who've come up. And for those who couldn't catch up for this session, this will be uploaded on our YouTube channel for the Clinician Engineer Hub. So feel free to subscribe. And we've also got our social media channels there. So that would be on Twitter, where you could find the Clinician Engineer Hub for future events on such exciting topics. Other than that, this is all from our side, and we hope you stay in touch and collaborate on more of such innovations in healthcare and engineering. Thank you so much.
Thank you, everyone.